Yes.
Yeah, of course.
Yes.
Everything.
Everything you ever taught us.
We are going to move on. Quiet, please. We're going to move on to section 7.3. In this section, we are going to graph square root functions. The first thing I want to do is start by talking about domains and ranges. They're not so bad. Finding these domains and ranges. Yes, it's recording. This is not an example you have on your handout, so I would recommend putting either in the margin of your paper or maybe in your notebook where your notes are. We're talking about how we can find our domain and range of this given function. So let's start by writing down the function into your notebook. We have f of x equals the square root of x minus 2. When we learned about square roots, we learned that we don't like to have a negative underneath the square root, right? Because what happens when we have a negative under that square root? Yeah, we have an imaginary number, sometimes called a complex number. Okay. Are we able to graph something like 7i or 2i? Are we able to graph that on our xy axis? Not yet. You'll learn about that when you get to vectors in calculus. But not yet. You haven't quite learned about that. So we want to stick with the real number system. So in other words, the numbers that you could put in for x. I could put in 2 for x, couldn't I? If I put 2 in for x, what do I get out? 0. 2 minus 2 is 0, and the square root of 0 would be 0. What happens if I put 1 in here? Well, 1 minus 2 is negative 1. What's the square root of negative 1? I. And we just said we can't graph that, can we? We don't know how to graph I. So when we talk about domain, remember that's your input value. So I want to think, what numbers can I put in for x so that I'm going to get a real number out? Well, in other words, I want what's underneath the radical, x minus 2. I want that to be what number or bigger? What's the smallest number that expression could equal?
2.
I disagree.
3.
I disagree. I'm not asking what x could be. I said, what is the smallest number that this expression right here, x minus 2, could equal?
0. 1.
0. Think about it. What could we put in for x to get 0? We could put 2 in, couldn't we? If I put 2 in here, 2 minus 2 is 0. What if I put something... It could be equal to 0, but what else could it be? It could be greater than. I want it to be greater than or equal to 0. I don't want this thing to be less than 0, do I? Because if that expression is less than 0, that's going to give me an imaginary number. And I can't graph that. And that's our goal today, is to do some graphing. So we've got an inequality here. You guys should love this inequality. Can you solve it? In your head, what is x? No, x is greater than or equal to 2. Okay? So this is our domain. So our domain, I'm going to use D for domain, is x is greater than or equal to 2. Now that's the smallest number I can put in for x, which we already knew prior to finding this, right? Now I want to know what's the smallest number I can get out. Well, to do that, we're going to find f of 2. We're going to put in this smallest input to figure out, I guess it would be either our smallest or largest output, depending on what the graph looks like. So let's do that. So let's put f of 2 into our function. We've evaluated functions before. We can do this. Michael, are you writing this down?
Yeah.
All brand new. I would recommend. So, of course, 2 minus 2 is 0. We have the square root of 0, which is 0. Now, our range is not 0. That doesn't quite make sense. And we'll get to the inequality here. Let's talk about this, because we put in 2, we're going to get out 0. Well, what if we put in 3? What are we going to get out?
1.
3 minus 2 is 1. The square root of 1 is 1. So my smallest input is going to be 0. What's another value I can put in? 1. What if I put in 6? 6 minus 2 is 4. The square root of 4 is 2. So This would be the smallest value, correct? So I'm going to say that my output, which is y, is going to be greater than or equal to 0. Greater than or equal to 0.
So our range is greater than or equal to 0.
Yes, our range is great. Y is greater than or equal to 0. Let's look at another function and find its domain and range. Here we have f of x equals the square root of x plus 4. Like in the last example, we cannot have a negative underneath that radical. So I want to state that that expression that's underneath the radical has to be what or bigger? It could be 0 or bigger. So how would I show that? Greater than or equal to?
Negative 0.
Can this expression be greater than or equal to negative 4?
Yeah.
No, it can be greater than or equal to what? 0. Can you solve this? X is greater than or equal to what? Negative 4. My domain. X is greater than or equal to negative 4. So let's move to our outputs. If negative 4 is the smallest number I can put in, let's figure out what the smallest or largest, depending on our graph, number we're going to get out is going to be. So let's find f of negative 4. Negative 4 plus 4 is 0, and the square root of 0 is 0. So this is the smallest number I can get out. How would I write my range? I don't want to just say f of negative 4 equals 0. That's not my range. Our output range is y is greater than or equal to 0. Look at the next example. F of x equals the square root of x plus 6, all increased by 2. Should I take 6 plus 2 and go ahead and add those? Say that's 8. Why?
It's outside the radical.
6 is underneath the radical and 2 is not, correct? So I'd have to evaluate this expression before I'd be able to add 2 to it. So when I'm talking about domain, does the 2 matter? Is it underneath the radical? It has no impact on the domain. So I want to say that x plus 6 is greater than or equal to 0. What is our domain then? X is greater than or equal to negative 6. Now to find our range, what are we going to do with negative 6? Plug it back in. Let's find f of negative 6. Don't forget the plus 2. That is important. Now, negative 6 plus 6 is 0. And the square root of 0 is plus 2 is 2. So if this is our smallest input, this is going to be our smallest output. So what is our range going to tell us? Y is... I'm sorry, I wrote R there, nobody stopped me. What should that be? D, thank you. Our range is going to be what? Y is greater than or equal to 2. Are there any questions with finding our domain or range? So the next thing we're going to do is we're going to graph. We're still going to find our domains and ranges, but we need to actually get a graph of these square root functions so we know exactly what we're looking at. And this is where you're going to move to the handout that I've given you. There are some graphs on the front and back. Please start on the front side, example A. The first thing we're going to do is graph this. If we're given a function or an equation that we have no idea what it looks like, how do we graph it? We have no idea where to start on graphing. You don't know what it's going to look like. Ow. Back in middle school, you probably learned how to graph this way first. How do we graph? What's some options? What? How do we get those coordinates? They'll help us. That's it. An XYT chart. When you guys first learned to graph, that's probably the method you learned, isn't it? You made a table, and you put values in for X. That's what we're going to do. Now, we just learned about domains and ranges of square root functions, correct? And we learned that we're kind of limited. We just can't put anything in for X. So the same thing applies here. Can I just randomly pick, -3, put it in for X? No, we have to know our domain, don't we? We have to know what numbers we can put in for X before we even begin graphing. So how do we find our domain? How did we just do it, guys?
Starting with the radical.
Okay, starting with the radicand, x minus 4. And what do we know about x minus 4?
It is greater than or equal to 0.
Has to be greater than or equal to 0. So we're finding our domain here, which is going to help us put into our XYT chart. Solve this. What are you going to do? X is greater than or equal to 4. Okay. So what this is saying is x is our domain, our input, correct? They're telling us that the smallest number we can put in is 4. But I could put in 5, 6, 7, 8 if I wanted to. So in our XYT chart, let's start with 4. 5, 6, 7, 8. Michael, write it down. Make you stand up. Yeah, write this down. We're in the first column. So into your function, let's do this. And you're going to need a calculator here. If you don't have one, you're going to need one. So by putting 4 in, 4 minus 4 is 0. The square root of 0 is 0. And 0 times 3? 0. And 0 plus 2? 2. Okay, so I want to go ahead and plot these points as I'm going through them. So I have the first point at 4, 2. Put a dot there, 4, 2. Second value I'm going to put in is what? 5. So let's do that. Put 5 in for x. 5 minus 4 is 1. The square root of 1 is 1. 1 times 3?
3.
And 3 plus 2? 5. So the second number I got out is 5. So we have 5, 5. Let's put our third number in, 6. Put 6 in for x. 6 minus 4 is 2. What's the square root of 2? 1.4. Okay. So let's do 1.4. We'll round it to percent here. 1.4 times 3.
4.2.
4.2 plus 2.
6.2.
6.2. Right now it just looks kind of like a straight line, doesn't it? We haven't picked enough points. This is definitely not a straight line. Let's put 7 in for x. 7 minus 4 is 3. What's the square root of 3?
1.7.
Okay, 1.7. So 1.7 times 3. 5.1 plus 2? 7.1. Let's keep going. Let's put 8 in. 8 minus 4 is 4. The square root of 4 is 2. 2 times 3 plus 2. 8, 8. Now, this is definitely not a straight line. I mean, we should be able to see that it's not quite a straight line, is it? Okay. Now, this is what I'm going to see a lot of. And this is wrong, so please don't do this. This is what people are going to tell me the graph looks like. What's wrong with this? Why can't it go past this point? What starts?
It can't be.
Lowest number, keep going. So Brandon, you're saying that the lowest number, the smallest number we can put in is 4, right? So like I couldn't put in, say, -2, my function. What happens if I put -2 in here? I'm going to get an imaginary number. Can I graph that on my graph? I put -2 here. Or excuse me, 2. So 2 minus 4 would be -2. I can't take the square root of -2 and get a real number, can I?
No.
So, Brandon, you're absolutely correct. I have to start here. My graph is going to go up and to the right. And it's going to gently curve off to the right. It's not linear, it's not a line. And actually, a graph is going in one direction, it's just curving off to the right. We know our domain, don't we?
Yep.
What about our range? How do we know?
You smash it against the wall.
Okay, we can smash the graph against the y. The smallest y value is 2. Look at your table. If 4 is the smallest number we can put in, that means 2 is the smallest number we're going to get out, correct? All these other y values, look at your table. All these other y values are bigger than 2, aren't they? So our y value, our range, is greater than or equal to 2. Let's keep going. Let's do another example. Let's go to example B.
Miss Fuller.
Yes.
On this one, do we have to graph our domain?
Do you have to graph the domain?
Yeah.
What do you mean?
Like, I don't know.
Well, our domain is x is greater than or equal to 4, right?
Yeah.
This graph is showing that.
Okay.
So we technically did.
Okay.
And that arrow that it keeps going on our graph indicates that our domain is going to keep going to the right.
Okay.
Okay, with our range. How about this one? This will probably be all that we have time for, because I want you guys to get started with some homework. So we'll go through this problem real quick. Let's talk about it. Michael, stand up. Take your paper, go to the back of the room, stand up. That's twice. I'm not telling you again. Please do it. First thing we need to know is what numbers we can put in, right? We can't even do our XYT chart until we know that. So it all depends on this radicand. That x plus 5 has to be what? Greater than or equal to 0. So what is our domain? If we go ahead and solve, x would be good. There's our domain. You've got your domain right now. Now I could put in -4, -3, -2, -1, 0. Anything that's bigger than -5, right? So let's go ahead and calculate some of these values. If we put -5 into our function for x, -5 plus 5 is 0. Square root of 0 is 0 times -1, still 0, minus 6. -6. Let's go ahead and plot these as we come up with these values. So we have -5, -6, down to 6. There we go. -5, -6. Next number we're going to put in is -4. -4 plus 5 is 1, the square root of 1. 1 times -1. -1 minus 6, -7. So we have -4, -7. Put -3 in. -3 plus 5? 2. What's the square root of 2? Okay, 1.4. 1.4 times -1. -1.4. Minus 6? Negative 7.4. Let's put negative 2 in. Negative 2 plus 5? 3. What's the square root of 3? 1.7. 1.7 times negative 1? Negative 1.7 minus 6? Negative 7.7. Let's put negative 1 in. Negative 1 plus 5? 4. The square root of 4? 2. 2 times negative 1? Minus 6? Negative 8. Go ahead and we'll put 0 in since we do have it in our table. 0 plus 5 is 5. What's the square root of 5? 2.3, or excuse me, 2.2 is right, I'm sorry. 2.2 times negative 1? Negative 2.2 minus 6? Negative 8.2. So clearly it's not a straight line, it's not linear. Now, we have to start obviously here at negative 5, correct? Our data is going in this direction, we could just keep it going. Looks different, doesn't it? Why did the graph go down? You know, the last one that went up. Because of the negative. Just like on a parabola that reflects across the x-axis, same thing with square root functions. It's going to cause it to go down. Okay? Cause it to reflect. Now let's talk about range. We have our domain. We know our range has something to do with negative 6. Now, are these numbers greater than negative 6 or are these numbers less than negative 6? Why is it going to be less than as opposed to greater than? It's the direction it's going. So we're going to say that y is less than or equal to negative 6. All right. We are graphing these square root functions. And I do have some that I want you to try. Now there's going to be a few graphing, a few you're just finding the domain and range for. We're on page 427. Let me get to that page. Numbers 8 and 13 to 22. We're not graphing all of these, so don't panic. We're not graphing all of these. There's just a few. You'll have to follow the directions. I think I've got four graphs, so you should have 4 graphs on your homework. If you want to do all of your work on here, you can. If you'd rather just do your graphs on here and your work on the other problems on another sheet of paper, you can do that as well. As always, guys, you're welcome to come in during the advisory work if you need a quiet place to get some algebra done, or any homework for that matter. Or just want me to check over your work and make sure you're on the right track. I'm happy to do that. You do have a few minutes in here. Let's go ahead and get started on that.